Hello, everybody. This is Paul again from the Ideas Lab, and we are going to go on to another fast tutorial focused on how to actually run fast. So in the previous two, we went through what fast is, and we also went through how to download it from GitHub. Now we're actually going to get into running fast. So let me go over to MATLAB. And as I mentioned in the previous video, the function that we're going to call to run fast is called main. This information is also in the README, both in the MATLAB form and in the Markdown form. Feel free to read whichever one you like. It will have the same instructions. I'm going to go through a quick example here to save you from reading. So one thing you'll notice about all of the functions in FAST before we actually get into sizing the aircraft is that every function within FAST has a standard function header. And this is documentation at the beginning of the function that you can use to understand more about it. So we always have the function call, who wrote the function, when it was last updated, followed by a description of the function. And then we also provide a list of inputs and outputs that the user either must provide in or can get out. So in this case, we have two inputs. We have the input aircraft, which is going to be a structure for all of the information about the aircraft's design, and profile function, which is going to be a function call to the mission profile that you want to fly. As a reminder, all of the aircraft specification files that are shipped with FAST are located in the aircraft specs package. All of the mission profiles that are shipped with FAST are provided in the mission profiles package. So before we go on to actually running main, we should probably take a look at the inputs and outputs. So I just explained the inputs to you, so I'll skip over that. The outputs are either one, an aircraft, which is the structure containing the information about the aircraft after it's been designed, and then also this table called mission history, which provides information about your airspeed, your altitude, what segment you were flying, how much fuel you burned, things like that throughout the mission. So the user can run main with either one or two output arguments. For simplicity right now, I'm just going to run it with a single output argument. And in a later tutorial, we'll talk about accessing the mission history, this second output argument. So what I'm going to do now is I'm going to select an aircraft to run and a mission profile to run. In a later video, we'll actually go through the inputs for the aircraft specification and the mission profile. Right now, we're just going to give you a high-level overview of how to run fast. So what I'm going to do is I'm going to run the example.m file that we provide in the aircraft specs package. And this example.m will be reviewed in more detail in a later video, but it basically models an Embraer ERJ 190 from literature. And to go along with this, I am going to use a parametric regional aircraft mission profile from the mission profiles package. So let me first write my output, which is going to be the ERJ 190, and I'm going to call the main function, and you'll see what I first have to do is refer to the aircraft specs package since the example file is stored in there. So I will type aircraft specs package dot example. And since this function has no input arguments, I can just leave it as is. And then we have to provide a function handle for the mission profile. So that means I have to put an @ sign first, and then we'll say at mission profiles package dot parametric regional. Okay, so now I'm all set to go. So I'll hit enter, and you'll notice that as the pre-processing happens, there are sometimes warnings that will come up, and that's okay. Another thing that may happen at the beginning is you may provide an infeasible aircraft design, so some things may or may not converge in the first few sizing iterations. And that is perfectly normal because as the aircraft design becomes more and more refined in the iteration, there will be enough power supplied by the engines, the aircraft won't be too heavy, so on and so forth. So it's okay if you get some warnings in the beginning. So what's going on right now behind the scenes is that FAST is sizing, and we will pick up once it finishes. Which was rather quick, as you can see, hence the name FAST. So now you'll notice that in our workspace over here, we have the aircraft structure returned to us, which is the ERJ-190. And we will take a second to explore this aircraft structure a little bit. So there are 5 fields in the aircraft structure. There is the specs, which is the aircraft specifications. So if we go into this, we can see things like the weight breakdown. So this is the MTOW in metric units that we converge to. The settings are all of the run settings that we used in FAST. The geometry is all of the geometric parameters that are used to create a regional jet geometry, and we'll talk about that in a later video. HIS data shows all the historical data that was used in the regressions, and then mission provides 3 things. It provides the profile function handle, the mission profile that you flew, and also the mission history, which we'll talk about in a later tutorial. But this has the mission history right now only in SI units, and we can go in and look at the altitude, for example, and you'll see that it records the altitude of the aircraft as a function of time. So now that you know how to run FAST and what is in the aircraft structure, in some later videos what we'll do is take a look at how you actually specify an aircraft and how to specify more information in the mission profile. So as we wrap up here, I would like to thank you for joining us, and stay tuned for another tutorial in which we will review the aircraft specification file that we used in this video, and we'll walk through each of the inputs and how you need to prescribe your aircraft configurations so you can create one on your own. So thanks for watching, and we'll be back soon.